Hey, fourth graders, it's Mrs. Spears. This is lesson 10.1, and it's on page 549. It's about lines, rays, and angles. Today we're changing topics, like completely, totally, 100% changing topics. We're not doing decimals anymore. We're not doing fractions anymore. We are completely moved on to geometry. And you can tell because the pages have turned purple. They're not green anymore. Green was all fraction stuff and purple was geometry. We did do some geometry back when in March. The first few weeks you guys were home. We did that chapters 12 and 13. So we're going back and we're doing chapters 10 and 11 for the rest of the year. So today kind of introduces you to some of the vocabulary that you're going to see, some of the notation that you're going to see, different ways these things are written, so that as we use them for the next couple weeks, you already have an idea of what each of the symbols and stuff means. So it says, everyday things can model geometric figures. For example, the period at the end of this sentence models a point. A solid painted stripe in the middle of a straight road models a line. So there are four main vocabulary words when you're talking about these types of things. These building blocks of geometry, I guess is what you can call them. First one is a point. It's an exact location in space. So this one is point A. So that's how you would read it and say it. Point A. And an example of that is like a dot. The end of the pencil is like a dot. Then you have a line, which is a straight path of points that continue without end in both directions. So here's a line. You can see it's got an arrow on both sides. Those arrows show that they go forever in both directions. Like if I kept drawing this line, it would go all the way out forever and ever and ever that way and forever and ever that way. It's just got some points on it that they have labeled, like the points like earlier. Point B is this dot right here, and point C. But actually, you can put dots wherever you want on this line and label them whatever you want. But to label this whole line, we use some, it's called line BC, because those are the points we have on it. And it's written like this. Let me zoom in here a little bit. It's written like this. You see these little tiny arrow lines at the top? Arrows on both sides to match the arrows over here. So this is line BC or line CB. Either way is fine. It depends if you look at it this way or this way. It doesn't matter which way. But the line indicates that it's going to be a line with arrows on either side, just like this, that like the line continues in both directions. And then the letters tell you like which line specifically. When you have a whole bunch of lines together, those letters kind of help you figure out which one is which. But it reminds you of like a roadway line. You think of a road that goes on forever and ever and ever and ever. It just keeps going. You also have a line segment as part of a line. So like if you were to take a line like this and take a chunk of it out, it's part of a line between two end points. So this is line DE, line segment DE. It's written a little differently. It still has a line at the top and it still has the letters underneath it. But you notice the line doesn't have any arrows on it. So that's the difference between a line and a line segment. This is a chunk of a bigger line. So this line is so long. So if it's got dots on the end like this, it means it's never going to get any bigger. It's just going to stay that exact length. If you have arrows on the end, it means that the line could get longer. And so be careful with the notation between those two. So like a line segment on the side of this yield sign would be from here to here. Here to here. It's not going to get any bigger. It's not going to get any smaller. It's the same length. It just stays put. And the last one is a ray. A ray is a part of a line that has one end point and continues without end in one direction. So this one is like a combination of these guys. It's got an end point, so it's not going to get any bigger this way, but it will continue on forever this way because there's an arrow there. So this is ray FG, and you write it like this. You've got, again, a symbol matches what it is actually as an end point and an arrow. Same thing here, end point and arrow, F and G. These guys up here, you could write them different ways. You could write like this direction BC or CB, DE or ED. With rays, your first letter matches where your end point is. So it's like your starting point. These guys don't really have a start or an end because this one goes forever both ways, and this one, it just depends on which way you look at it. So you use the starting one with the end point and then go out forever from there, and you start that with your name as well, just like the arrow here. So activity 1, draw and label line segment, because if you zoom in, it doesn't have the arrows on it, so it's line segment JK. So I'm going to draw a line segment, which means I have a line with 2 end dots on it, line segment, and I'm going to label each of those dots with those letters, J and K. Is there any other way to name J and K? Or line segment JK? Absolutely there is. You could also flip it around. You could label it like this, or you could leave it the way it was. But this can also be written as line segment KJ. It's referring to the same line. So these little symbols with the letters just tell you it's the name of that, whatever it's talking about. So this is the name of this line, and this is the name of this line. But these two lines are the same. They're just backwards from each other. So either one is a way to write that. You could also use this way to write this one if you want to, and this way to write this one if you want to. All right, turn page. I'm on page 550. We move on to angles. Now, angles is where all of this is important and all of this comes in handy. The line segments and the rays and all of that, they are what build angles and geometric figures, which we'll get to in a couple of days. So it's kind of like if you were to take Legos and start putting Legos together to build something else. That's what this is. These are like your Lego pieces, and this is what you end up building with those Lego pieces. So it says an angle is formed by 2 rays. So they have an end dot and a line that goes on forever. 2 rays or line segments, so it could also end too, that have the same end point. So they share an end point. The shared end point is called the vertex. So this, if you want to label this part of an angle, is always going to be called the vertex. Okay? And it's going to be made up of a vertex that connects either 2 rays, like this one, or 2 line segments. It could be that too. And how you read that, if you were to describe this to somebody, you would say, oh, that is angle PQR. Or you could say it's angle RQP. So it could be either one of those 2 things. It can also be called angle Q. What's important about when you're naming and writing angles is that the vertex point is in the middle of the name. So if you look at these guys, all of these are different names for this angle, but they all have one thing in common. They all have share Q as a middle part. And this guy is just by itself, but it still counts. So when you're writing angles, you're going to write the symbol. So like the other ones had the symbol with the arrows and stuff like that. Here's your symbol is the angle. And then you're going to make sure you name it so that the middle one matches your vertex. Okay? Otherwise, you won't be naming the angle correctly, and somebody may not know which angle you're referring to. So an example of that would be like a piece of pizza. Here's my vertex. That's point Q. And then I could draw up to get a P over an R. Okay? So that angle matches that one. And there are different kinds of angles. This is what it means to classify angles. Angles can fall into different kinds of groups. They can either be a right angle, which forms a square corner. So that little tiny blue box right there tells me that that corner is exactly a square, right on the edge right there. A straight angle forms a straight line. So this is actually an angle, even though it just looks like a just plain line, because it's still 2 rays stuck together. So even though it looks like it should be one continuous line and we should name it that way, it actually has the vertex in the middle. So it's because it's 2 put together. And then I've got the acute angle is less than a right angle. It's skinnier than this one. And you're looking at this part right here, the inside part. If this looks to be smaller than a right angle, it's an acute angle. However, if it's bigger, it's going to be an obtuse angle. And how I like to compare them, I always like to draw like a fake right triangle on top of it. So there's my fake right triangle. Well, this angle line is smaller than that fake line, the fake right triangle line, so that means it's an acute angle. But this one, if I did a fake right triangle on it, this one's bigger than the right triangle, which makes it something called an obtuse angle. Sorry, I said that wrong. Obtuse. So this is an activity that you could do at home on your own. I don't have a piece of paper handy, but this is something you could do to kind of help you compare if you want to. Like I said, I kind of just draw in the fake right angles, but if you do this and you fold the paper the way they show you, fold in half and fold in half again, the corner of that angle will be a perfect right angle, as long as you fold it neatly. So it says to classify an angle, you can compare it to a right angle. Like I said, I don't really carry one of those around with me all the time, so I just kind of draw it in where it would go. So like for this angle, I know I'm going to draw like a fake right angle, so that makes a perfect corner. This one is bigger than my fake right triangle, so I know that this is called an obtuse triangle. Or obtuse angle, sorry. It's not a triangle. And then I've got this one, same thing here. I'm going to take one of the lines and I'm going to draw a fake right triangle on it. This one is smaller than that right triangle, which means it's an acute triangle. Get it? It's a cute triangle. It's so cute. Funny. Okay, and then this one's a little trickier because it's very close to being right on exactly. But I draw in my fake one. This is one you might want to get out a piece of paper and check it because it's really, really tight right there. But it's still just tiny, a bit smaller than the one I drew. So that makes an acute angle. This one over here, if I were to take the line and draw a fake one on top of it, it would fall right on top of the one they already gave me. And that one is a right triangle. So we're going to classify that angle as a right angle. Sorry, I keep saying triangle. We'll get to triangles in a couple of days. But we have to understand these classification of angles before we can start to classify triangles. So like I said, a right triangle, a right angle, I keep saying it, a right angle makes an exact corner right there. Acute is anything smaller than that. Obtuse is anything bigger, and a straight line is anything that's exactly sideways like that. All right, so I'm on page 551. It says draw and label line segment AB in the space at the right. So line segment AB is well, let's see here. I'm going to draw it. So it's a line segment, so it's got points on both ends. A, B. So because this has end points at both sides, it doesn't have the arrows on it. This is a line segment. So these problems on this page are having you take some of this new vocabulary that you've learned, the different types of angles and the different types of line segments, raised lines, that kind of thing, and it's having you classify the description they give you. So for this one, you can see it's got an arrow on both sides. So this is line XY. So draw an example of the figure. So line XY, I'm going to have a line that goes in both directions, arrows in both directions, with points X and Y on it. Again, you could have those backwards if you wanted to. It doesn't matter. I just wrote it in the order that they're on there. So this one says obtuse angle K. So if I draw in a fake right triangle, right angle, I keep saying triangle, no! Here's my fake right angle. Okay, I know an obtuse is bigger, so I'm going to draw the bottom part of the angle, and then any size that I want over here, as long as it's bigger. It could go here, it could go here, it could go over here, as long as it's not straight and it's not small here on this right side or over here, it can work. So anywhere in between those would count still as an obtuse angle. So because it's obtuse angle K, I'm going to label the vertex with a K. And then I can always go back and erase that. So there's an obtuse angle. So this one is right angle CDE. So I'm going to draw an exact right angle. I don't have to do a fake one this time because I can just do a right one. And I put that little box in there to remind whoever's looking at this that this is drawn exactly with that square edge right there. So I've got a point here, a shared point, and a regular point. And a CDE, remember the middle one describes the vertex. So I can put that one in there. So CDE. All right, this one says use figure M for 5 and 6. So these two, you're going to use this picture over here. So I'm going to draw a line there so I don't get confused there. It says name a line segment. So there's lots of different answers with these. You're going to find that a lot of these questions have lots of different answers with them. So a line segment for this one would be any line that has 2 finished endpoints. So you could use the line segment VT or TU or UW or WV. Any one of these 4 edges counts as a line segment. So I'm just going to write one of them on my answers, but any one of these 4 can count. So I'm going to do line segment TU. But like I said, there's 4 possibilities on here. Most of these questions, I mean, unless you are doing, actually, honestly, most of these have more than one right answer to them. As long as they fit the description that you're given, they still count. And this one says name a right angle. Well, on this picture, there's only one right angle actually noted on here. So I'm just going to use that one. So I'm going to say name the angle TUW. TUW. Could also do WUT as long as that U is in the middle. That's what counts. So this could be WUT as well. So just make sure that doesn't look like an L, okay? Kind of like mine did. So angle. All right, draw and label an example of the figure. This is a ray from point P to point Q. We know with rays that the end point is whatever the first letter is. So ray, P, Q. Acute angle, RST. So I'm going to draw on my fake right angle. Acute is anything smaller than that. So I'm just going to pick, just pick over here. So that is smaller than this, and that's what matters. Okay. Then I can erase all my fake lines here. RST, so the S has to be at the vertice, or the vertex. RST. Again, yours could be a little bigger than mine as long as it's not bigger than a right angle. And long as it's not as small as a ray, make sure it's somewhere in the middle there. And then straight angle, so I know it's going to look like this. I don't have to draw the fake right one on this one because straight ones are exactly a straight line. Middle letter is X. So then the other letters go on either side. All right. Normally I would have you pause the camera or the video and then do this on your own. I don't want to do this with you because like I said, there's lots of possible answers that you could choose for this one. I'm only going to write down one for each one, but there's other answers to this too. So the first one says name a ray. So you could have picked any one of these rays that you see on here. The first one that sticks out to me is ray BK. That's one I saw first. But you could have done ray BA or ray BJ or ray RP or ray RQ. It just depends on whichever one you want to use. It's fine. As long as your ray has an end point. So there's my end point for mine. And then it goes out in one direction forever, which goes to this one here. So that's my K. So name a line. So it's talking about a line, not a line segment. So it can go in either direction. You could have chosen this line here, or this line here. The biggest one that stuck out to me, I picked the biggest one. So line AC. Line AC. Like I said, you could do line JK, line QP. It doesn't matter as long as you have a line symbol and it matches the description. Name a right angle. Right here they name this right angle for me. So that's angle PRC. Angle PRC. Name an obtuse angle. That would be ABK. This one, I think, I'm going to double check it with using my fake right angle test. Yep, that one is bigger for sure than the right angle, so I can use that one. That's angle ABK. But you could use, here's another obtuse angle here. You could use that one as well. This is a right triangle, and so are a right angle, and so are all these guys. So really, it was only those two answers. Name a line segment. Any line segment you want. It could be AB or BR. I'm going to go with BR. Why not? So line segment BR. And an acute angle is anything smaller than the 90 degrees. So I'm going to just experiment on this one again. Here's my fake right angle. This one, angle KBR, is smaller than my fake right angle. So I'm going to use that one. Angle KBR. But like I said, there's lots of possible answers. Just make sure your answer fits the description. Okay? Alrighty. If you join me for Zoom today, I will be doing this next page with you, the homework page. Don't worry about these extra ones today. These are just for fun if you want to. I do them with you, but your video is already at 20 minutes, and I want to make sure you have plenty of time to work on your paper. So I'm going to go ahead and stop it. If you have any questions, send me a message or join me for Zoom. Bye!